I'm so glad that we get a chance to talk today. We've been working on things together. We've had quite a history now. If you guys wouldn't just give us a little bit of intro on how you came to find out about MakerPipe.
Dave, I had seen your stuff online. I don't know how I found it, but just the name was compelling because, I'm interested. Well, we are interested in what people are doing with the tools that allow them to make different things, like 3D printing, for example. So I saw your name and I followed it up and went to the website and looked what you're producing. And at the time, and I don't know when that was, I thought to myself, I'm going to use those for something.
And you guys have a lot of history in engineering and also have a design firm, Martin Product Design. Can you guys tell me a little bit about your history with engineering and the firm?
I'm an engineer by training, and I spent 28 years at a university teaching engineering. And I've always been involved in design of some sort or another. So Liam and I started this firm in 2013, and we have a couple of products on the market now, and we work on a variety of different things. I for sure love engineering and design. I think that's true for Liam. Liam is not an engineer. Mm-hmm. He tolerates engineering. That's a good thing about it.
Yeah. And I mean, when we started talking, what struck me really intensely is your guys' love for finding solutions and creative design and problem solving. And then layered on top of that, this interest in creating efficient structures was something that really jumped out to me as we started talking about the possibilities. And it sounds like, this has been a topic that you've thought about a lot over the years.
Yeah, we have worked on them for a variety of things. In fact, it was a structure for storing airplanes that are left on the ramp was one of the first things that we did. Mm-hmm. And, so we started talking about tension fabric buildings at that point. And so we actually ended up incorporating that idea into this structure here.
I mean, that passion came through when we started talking all those months ago. And it really got me excited too, because, I'm not an engineer, and there's a lot of things that I really don't know about making structures. And the opportunity to take what Martin knows about engineering and your guys' passion and marry that up with our ability to make connectors and think about things in a low cost kind of creative way. It was a really exciting promise. And you guys already were down the road with the Siglo structure behind you, and you were customers. So I really appreciated that. It's one thing when someone approaches me with an idea, but you guys are already putting it into practice and enjoying it. So that really meant a lot. You want to give us a brief introduction to the Siglo?
So this is a friend of mine's house. And August 11th, he was riding his bicycle with some friends and had an atrial fibrillation event that a lot of people were expecting that he would die. And because it was so serious, they thought that maybe he hadn't received any oxygen for up to 15 minutes. And those of us that time with them really liked him. And so we were very distressed by this. So as he got healthier, we started thinking, what are we going to do to make sure we get to spend time with him? And this was, of course, right in the middle of the pandemic. So we thought, it's getting cold here. It was November, but maybe we can build a structure that at least we can spend some time together outside. And so I said, okay, I'm going to design something, which I did. What you're seeing right now is one end of it. This structure is 12 by 12. And because we wanted to be able to put 4 couples each sitting in a corner so that they would be socially distanced by at least 12 feet. So it's very big. And when we built it for the winter, we had walls all the way around the bottom of the building. Those walls have been removed for the summer. We didn't know how long the building would actually stay up, but it's such a wonderful space that the owners of the house and my friend have really wanted to keep it up. It's kind of funny because we told them we wanted to put up some structure, but they went away for 5 days, and while they're gone is when we built it. And they came back. And notably, this guy's spouse was like, what is that thing? But she's a wonderful person. It's turned out she really likes it. And so she often has guests here as well.
That's great. I'm glad she came around.
So we meet here frequently. We have added various decorations. And in fact, somebody made a sign for it, calling it the Siglo.
What is it a portmanteau of?
Siglo C stood for COVID. but we eventually changed that to S. So this sign's out of date. S meaning social distancing. Igloo is what we were thinking. And what's been amazing is how comfortable this space has been in such a wide variety of weather conditions. We've been in the building when it was as cold as minus 10 degrees Fahrenheit, and it's 80 plus today, and it's very comfortable in here. So very nice space.
Minus 10 degrees. Wow.
Yeah. Oh yeah.
That is pretty cold.
And it was cold out here, but we brought heated blankets out in the whole bit, and as you can see, we've done some things. Some of the people are runners and so forth, so those are medals and all that kind of stuff. So it became very much of a community space. So these kind of spaces are important. And the one thing that I've noticed is that whenever we're out here, we're engaged in conversation. There's nothing else to do,
Do you remember how many connectors we ordered for it?
It was a lot.
60 some, or
I
can't remember.
It could be. You see, they're all over the place.
It's a big structure. I mean, you described the size, but there's a lot to it. And when I see something like that and hear that story, I mean, it warms my heart. It's great to hear that it's being used in a way.
This has become sort of our clubhouse, and I don't know when it's coming down in February.
That's impressive. And I know over the months that we've been talking, not only has it been minus degree weather, but it's also been up in snowstorms and wind too. Is that right?
It really has not had any problem at all. One of the reasons that I was so attracted to this was the ease at which of getting a 45-degree roof, because when I read about that, it seemed like 45 degrees sort of meant that snow would not stay on it. And sure enough, snow slides off it.
Hey, could you tell us what you have draped over the maker pipe and the EMT?
It is a vinyl mesh tarp. We wanted some solar heating in here because we thought we were only going to be using this in the winter. That tarp transmits 80 or something % of the solar radiation, and you can really feel it. But the other thing about it is it was very cheap. That big tarp there was $40. It's a stock tarp and been very tough. But again, I think it's tension. And what I mean by tension is that we've got ropes on both sides.
This is the most important tarp in the structure. This one that it forms the roof. So the central seam of the tarp goes right over the upper ridge there.
Yeah, that's really high up there.
Which is another big advantage to that steep roof slope, because nobody feels like this building is small. You can see we have these ropes that are pulling on the tarp. One thing though we did learn, and we've been done this right away, is we need these tensioning rope and so forth and things like ratcheting straps. So we don't want it to move either direction. We don't want to move any direction.
Wow, it's really impressive. And I get a lot of questions about customers and the community asking, how can they make bigger structures? I don't feel experienced enough to guide them on how to make a structure of that size and utility. And then when I see the Siglo and what you've created there, it's super exciting for me because it gives the system, I think, new life and new possibilities.
I really like the idea of enabling people to make things and find solutions with products that are already available. If you don't have to reinvent the wheel every time you want to do something, that's really nice. The fact that you can use maker pipe and then commonly available tarps to make a structure is really appealing to us.
Yeah, and I think that's where we had that common headspace, and I think a lot of the maker pipe community really appreciates that. Let's kind of talk about where we've taken things since you guys originally built the Siglo and we started talking, because we just kind of fit into this weekly rhythm of the three of us talking and kicking around ideas with the aim of how do we help people do something similar, right? Or even beyond, how do we help people solve a problem that a structure like this would be helpful for? I can remember early on, there were some certain things about the connectors that together we could possibly improve. The weakest part of maker pipe connectors is because it's just friction holding on to that piece of conduit, clamps on. But we first kind of tackled that one piece of conduit pulled out of the end of a joint. How can we prevent that from happening in a structure like this?
I think you knew that there was a possibility for improvement. And I think you did a great job in challenging us just a little bit to say, okay, so let's improve these in a way that makes sense for us. Found that challenge to be fun. Obviously, the more I looked into them, the more I thought this was really a valid approach to extending their usefulness.
It was something that we tried to take a iterative approach to. At MakerPipe, we're all tooled up for this one connector, and changes to that design do take a lot of tooling. So what's that one step that we could do to try and improve the connectors for something like this?
So when I think about the connectors, there are two things that I would like them to do. And I want to make sure that they hold the EMT in place so that when we got whatever the original dimensions of everything set, that the EMT will not move in the connectors, because of course then you're going to lose potential connections. And then the second thing is I'd like to make the connectors handle as much load as they can. You can now see we have these three big trusses in here. And originally what we did in order to prevent these guys that are going 45 degrees up from spreading, from getting loaded, we tied ropes across here. It was hard to keep them tensioned. I think, David, that's when I talked to you and said, look, why don't we try something like this? You sent me some connectors, and I figured out that if we drilled some holes in those connectors and then used self-tapping screws into the EMT, we were going to get potentially a really nice, solid connection. So the next question was, well, was that hard to do when you were doing assembly? And it turned out that a good battery powered drill would allow you to do this, even with these pieces in place. And so you can see we got one of those screws here and one of those screws here. I put the connectors on with the self-tapping screws, then brought in the pipe and that central bolt that you guys use. So you end up with a spectacularly nice connection there.
Right.
We did this shortly after we first put up the Siglo. That's where we've got the revised connectors, is on just 3 parts of the truss. And it seems like so far that's all we've needed. At least hasn't fallen down, so that's good.
The fact that it fits into the process of assembling the connectors like normal. I had customers talk about drilling all the way through and running a bolt and a nut, but the self-tapping screw that you found and the way that you spec'd out where those would be really brought everything together in my mind.
It may actually simplify construction for people, because once you put that together, that joint's not coming apart. It can handle a lot of load.
Possibly this could be a kit, right? That if someone had this need and needed a little bit of help, but also wanted to do some of the work themselves for a better value, we could easily offer a kit to get them one step closer. Kind of here, our process at MakerPipe is we get orders all the time where somebody's ordering 5 of these and 4 of these. So we're used to making a kit, and we could, with some design work and some documentation, make a structure kit or a Siglo kit.
Yeah, we're still excited about that idea.
These structures, if there were other geometries in the trusses that might provide some increased capacities and combinations of connectors with EMT, that got quite impressive in what they could handle.
Because I think those lessons learned from doing the analysis, it showed me a lot and kind of informed how we moved on from there.
For example, for this 90-degree connector, which we haven't utilized in the Siglo, but if I ever take it down and we put it back up, they're definitely going in. And you can see there are 6 of these self-tapping screws in addition to the ordinary bolts. Suppose this was at the top of the roof, let's say.
Mm-hmm.
What we're seeing is the hole through which the ridge pole would go. And if you load the roof, a lot of it ends up on that webbing on the lower surface of this connector. One of the reasons those 2 screws on the top are there is because now the EMT itself will add to the strength of the connector by putting those top two screws into the EMT. The EMT is also sharing the load that is going to tend to try to cause this thing to straighten out. So overall, the connector becomes much, much stronger. So by putting the two self-tapping screws in each of the legs, you're going to fix the EMT. So the EMT is not going to move, and you'll transfer loads from the EMT to the connector through those screws. A big improvement if you're interested in handling more significant loads. The other thing is some stress analysis. So this is an example of loading the connector, and assume that this is part of the roof structure, and that the ridge pole, the top of the roof, is going to go right through that connector. At this point, this simulation was done with none of those screws or anything involved in there, and no EMT in the top. Suppose you took a vertical force and you pushed right down on the top of the connector. What would happen on the bottom of the connector? You get above the yield strength of the material, and so the connector would actually bend.
Can you define webbing for us?
The top piece, the round section that fits around the EMT, the bottom piece has that section that fits around the EMT, but there's sort of a web that keeps the whole bottom section together, Liam. That's where we find our highest stress, and that makes total sense. If I'm trying to spread those two arms out because I'm loading them, the stress is going to be concentrated right at that webbing point, and that's what this analysis shows. And it wasn't intended to hold load.
No, certainly. I mean, it was just a function of making that right angle.
Exactly.
Then realizing, that was such a critical part of it. Great lesson learned for me anyway.
It makes sense, again, for us to think about a combination of the connectors and EMT in order to put together a structure that is able to handle high loads. And this is, of course, a truss structure. There is 1,000 pounds of force being placed on the top of that connector. Now, what's a little unusual about this is, you guys see green arrows down at the bottom of the picture there?
Yeah.
I was progressively testing what were the critical issues, and I fixed the EMT down at that point so it could not move in space, because I wanted to see how much bending and so forth there was and how high the loads were. If you look at the von Mises stress and you see the yield strength is 2.2 times 10 to the 8th Newton meters squared, and the maximum stress we actually see in this structure right now is half that. Put 1,000 pounds on it, it would handle it. So that surprised me. And it just shows that MT is actually pretty tough if you constrain its motion.
A lot more is possible than originally thought with Conduit.
Is this reasonable? And it sure does look like it is. This is what's called a deformation plot. In other words, it greatly exaggerates the deformation that would actually occur from loading it. I mean, this might be 100 times how far it actually moves or how much things actually bend. What's interesting about it is, again, you can see that we're way below the yield strength of the material. This is something that when you load it, it would move a little bit, but it would handle it. That's good to see.
I truly appreciate that work that you put into doing this analysis, because it's something that takes experience and know-how.
Again, it's a really spectacular material in so many ways, but you do have to remember that it's pretty thin-walled, and it gets longer, it loses some stiffness. So you got to design for that.
Yeah, just work around that constraint or that challenge. But I mean, it's certainly, you've proved there with the Siglo and just the community examples that I can think of. A lot of people have proved that's a great material to take advantage of. And that's why a kit seemed like the logical next step, because you can still customize it to whatever. If somebody needs a greenhouse, great. They can customize this idea to a greenhouse. Or if they need a storage shed, they can customize it to that need, whatever size it may be, but still fitting within the confines of the lessons learned, with the work that we've done, what people use it for and what the community thinks, and where other minds can possibly take it. That's a really exciting part of it. The community is an extremely big part of Maker Pipe, and you guys are part of that community and other people's minds. I think it's an exciting thing to put out into the world and see what comes back. I think it'd be good to kind of mention what our plans are as of right now, as of having this conversation. We've got customized connectors in process, producing those that are almost ready for testing. And then we've got a design that we think could be a possible kit.
Yep.
I'm really excited about getting those things finished and out there so people can check them out.
If people feel like seeing what we're up to, they can go to martinproductdesign.com.
Yeah, we sure will. What we're doing here with MakerPipe is just a small part of what you guys do as a company, too. You got some really neat products like the free reel.
It can wind cords and hoses, and it uses a unique technology to do so in a way that keeps the cords and hoses organized that other reels don't do.
And a really unique solution to a problem that a lot of people run into.
So if anybody's interested, they should absolutely feel free to contact us. We'd love to talk to them. Well, fantastic. This was fun.
Special thanks to Liam and Jay from Martin Product Designs. I had a great time talking with you guys, as always. Really appreciate your interest in MakerPipe, and their design is just really cool. Takes MakerPipe to the next level. I'm so excited. Stay tuned for that. We're going to do some videos. We're going to build one of these designs and possibly even doing a kit. So thanks everybody for watching. We'll see you next time.